So in the last video we talked about population variance and standard deviation. So in this video we are going to talk about sample variance and sample standard deviation. Again, very, very similar. There's one little change in the formula that we have to make sure we acknowledge. Other than that, as far as the technique of finding the sample variance and the sample standard deviation, it's very similar to what we were just doing. So let's go ahead and get started. So sum of squares, actually the formula looks exactly the same as it did for the population. The biggest difference here is in the denominator. You'll notice that instead of having the capital N for the population size, we have the lowercase n for the sample size. Okay, that's really, but it's the same formula, just a little minor switch there from a capital N because it was a population to the lowercase n because it is a sample. Then now the next part is where you're really going to see the difference here. So notice in the variance, it is no longer just an n, it is actually n minus 1. So when we find the sample variance, we actually need to do n minus 1. So that means if I had a sample of 10, I would need to do 10 minus 1, which would mean I would be dividing by 9 to get my variance. And we actually call this a degree of freedom, and we're going to talk more about degrees of freedom when we get into our t-tests later on in the semester. Alright, so let's find the variance for this sample. So I have the data set 2, 3, 8, 4, and 6. Again, starting off, it's going to look exactly like we did for the population. We need to find the sum of all of our data points. That's our x's there, the 2, 3, 8, 4, and 6, which happen to sum up to 23. The next thing we need to do is we need to square all of those data sets. So we're going to square and we get 4, 9, 64, 16, and 36. And again, we're going to add all that goodness together. It gives us a sum of x squared as 129. So then to find our sum of squares, we're going to do our sum of x squared, that's our 129. Divided, or minus, excuse me, 23, which is our sum of our x's squared, divided by 5. Again, remember at this point, the formula looks exactly the same. There's really no difference between what we're doing from the population variance to the sample variance. So 23 squared is 529. 529 divided by 5 is 105.8, and then 129 minus 105.8 gives us 23.2, and that is my sum of squares. Now remember, to find my variance, I need to take my sum of squares and I need to divide it by n minus 1, so this is going to be 23.2, and then 5 minus 1 in the denominator, so I've got 23.2 divided by 4, which is going to give me 5.8. I do have an error on this slide and I want to make sure you understand. Notice that here on my formula I went ahead and I have the sigma here. It really should be the letter S. For variance, sample variance, we changed this to the letter S instead of using sigma, and I apologize, I'll fix that on the next video. But just make sure you understand that that should be an S because I am dealing with the sample variance. Alright, so let's talk about sample standard deviation. Again, standard deviation, all we have to do is take the square root of whatever our variance was. So if we look for the standard deviation of our data set, we know that the variance is 5.8. So we're just going to take the square root of 5.8, which happens to be 2.41. And you might want to look on your homework and see where it asks you to round your answers. Typically, again, we want to round to one more decimal point than what our data is. So really I should have rounded this to 2.4, but that's okay. It's not that big of a deal to have it one more than what it needed to be. Let me know if you have any questions on how to find sample variance or sample standard deviation. Again, it's extremely similar to what we were doing with the population. The biggest thing to remember is when we do that sample variance on the denominator, it's instead of being n, it's going to be n minus 1. So the sum of squares divided by n minus 1. Again, if you have questions, let me know.